Start the class? Yes, Safan. Since the sessions I have to leave because of some issues, so I'll be your physics teacher from now onwards, right? So how many of you like physics? Just tell me. Morning Tejas, how many of you like physics? Just raise your hand. And how many of you don't like physics? You can message. Tell me. Apurva like it. Safan's favorite subject is maths and science, physics. Very good. No issues, Shivansh, no issues. Because I'll be recording the class. Okay, so I'll be recording the class. So you can just go through the recording and write your notes. Okay. Very good, Piyush. Now, before starting this lecture, right, before starting this class, right, today is the first class of physics for you guys, like which I'm taking. So we will just have a normal interaction about physics. Let's see what you know about physics. Okay, because physics is not just about equations, right? It's not just about theory. It's about how things happens around us. Don't you think? Right? For example, if I'm speaking, there's physics involved in that. If I'm writing anything, there's physics involved in that, right? If you guys are listening anything, if you guys are watching anything, everything is associated with physics. For example, suppose if there's no physics, right? Can you use your mobile phone? Think about it. Because when you talk about anything around us, anything, your mobile phone, your laptop, or a bird flying or an airplane flying, whatever is happening around us is somewhere associated with physics. Yes or no? Tell me. Right? So let's start with the basic idea about physics. Okay. I guess we have lots of time. Lots of time, it means uh, we have completed 3 chapters, right? Tell me. Sessions has completed 3 chapters. Chapter 4, chapter 5, chapter 6 is remaining. Yes or no? Now, in that, chapter 4 and chapter 6 are theoretical chapters, right? They are not conceptual chapters. So it will be completed very easily within 1 or 2 classes. Okay. So we will focus more on this light chapter. And do you want to learn something extra, guys? Tell me. Okay, natural phenomena half completed. Very good. Now, do you really want to know, like, learn something extra, something new in physics, right? How physics started? What are the terms associated with physics? Yes? Okay, very good. Okay, very good, everyone. So let's start with the basic fundamental terms. Okay, when we talk about physics, what pops up in your mind? Tell me. You like inventions? Okay, very good, Safan. Now think about it, right? Let's talk about physics for now. Okay, right? I'll just think about why there's only 15 students. There are 25 students. There should be 25 students, right? Can anyone note down the students who are absent, because I don't know the students, right? Okay, if any one of you can note down the students, then it will be quite good. Okay. Yes, so physics is a branch of science, right? Physics is branch of science which deals with phenomena which occurs around us. That's a basic loose definition of physics. But when you talk about basic phenomena, right? When you talk about basic phenomena, okay, we talk about physical terms, physical parameters. Think about it. And Safan, message to host. You're messaging to co-host. Okay. Nishika, good morning. You're messaging to co-host. Okay. Now, when we talk about physics, right? We talked about physical terms. Let's think about physical term. Okay, let's know what are the physical terms that we already know. Physical terms, right? I hope all of you know what is the meaning of physical terms, right? Physical terms means the terms in physics that we have already studied. Now, tell me, what are the physical terms that we already know? Just name it, right? Matter. Okay, matter is in chemistry, right? Friction, force. Yes. So I'll start with a very basic one, right? Very basic one is distance, right? Distance. Then displacement, right? Okay. Yes. Force. Very good. Pressure. Now, motion is basically your motion is generally a chapter, right? When you talk about motion, the parameters associated with that is velocity, displacement, acceleration, right? So I will write it down. Velocity, acceleration, speed, sound. Okay. Now, when you talk about sound, okay, there are different terms. Volume and sound are same, right? Ductility is again, yeah, you can say that ductility is basically both chemistry and your physics, right? But for now, we are not including ductility, right? Friction, yes. Friction. Friction is also kind of force, right? Anything else? Okay, volume. So volume, area, length, all are kind of related with this distance only. See, again, motion includes this velocity, acceleration, speed. Okay, got it. Mass and weight, very good. Mass, right? Yes, charge is one of them. Very good. Charge. Light, yes, light. Okay, right? Yes. So I guess we have studied or at least like heard these about these parameters. Yes or no? Tell me, yes or no? Right, Nishika? Everyone? Yes. But have you ever thought that what is the relationship between these parameters, right? Like there are numerous, like there are infinite number of physical parameters. They are called as physical parameters or physical terms, right? But there are many physical terms. How to remember all of them? Okay. Or for example, when you talk about, just think about the word. How many words are there? How many English words are there? Infinite almost, right? You cannot count them. Yes or no? Right? There are many. But when you think about it, right, they are actually made up of only 26 alphabets. Yes or no? Tell me, yes or no? Yes. Now, don't you think that we should have the same kind of thing in physics also? Like, obviously, there are different physical terms, right? There are many formulas, but they should be made up of some fundamental formulas, some fundamental terms. Yes or no? Think about it. Yes, right? Think about it. Doesn't it seem like intuitive, right? How can we study all those? There should be some fundamental physical terms which is responsible for the formation of all the physical terms, whatever we study in physics, right? Yes, that happens. Okay, so basically we have 7 fundamental physical quantities. 7 fundamental physical quantities. Got it? 7 fundamental physical quantities. And almost all physical quantities are made up of these 7 fundamental physical quantities. Now, can anyone tell me what may be these 7 fundamental quantities? Tell me, anyone? Start with anyone? Just tell me. First physical, because whatever we studied, right? Whatever we studied here is your physical quantities. Yes. So it's not meter, it is basically called as length. Length. Very good. Very good. Time. Very good. Time is second. Third, mass. Very good, Jalen. Mass. Right? So time, length, mass. Okay. Now hertz is frequency, which is again your time. Yes, electric current. Very good. Electric current. Energy is again, energy is derived. That we will study. Temperature. Yes, very good. Temperature. So these five are the one that we have to study. Okay, right? We will be studying this in our class 8 only. The next two, right? Yes, someone is Googling. Okay, so the next is something called mole, right? And then next is seventh one is something called luminous intensity. Luminous intensity. So these two we won't be studying in this year, right? But these five we will be studying this year itself. Okay, right? Now think about it. When you talk about these physical quantities, right? There are two things associated with that, right? One is called as unit. I hope all of you know what is unit, right? And second is something called dimension. Now, what do you think? What should be the dimension? When you talk about your name, suppose when I talk about my name, right? It is Vishnu Dev. So instead of that, sometimes I write VD, right? Short form, yes or no, right? So sometimes we use this short forms to represent some names, right? For example, when you talk about our surname, okay, so instead of writing, suppose Tejas Patil, we will write Tejas P, right? Or T Patil, yes or no, right? In the same way, right? Dimension are the short forms or of these physical quantities, right? And units. Now, when we talk about any physical quantity, is it right? If I'll say, right, give one potato. Suppose you go to a shopkeeper and say, give one potato. What shopkeeper will do? Tell me. What shopkeeper will do? Think about it. Because how can he know that you're asking for 1 kg, one bag, right? How can he know, right? Or you'll ask, give me one oil, right? It doesn't make sense because there should be some measurement. Yes or no? There should be some measurement, right? So what can I say? What is unit? Tell me. If I ask you what is unit? Unit is basically the measurement. Yes or no? Tell me yes or no. Right, everyone? So when you talk about length, right, we have different type of units. So here we are talking about SI unit, right, which is your standard unit. Okay. Now when you talk about standard unit, okay, the standard unit of length is meter, right? It is represented by small m. Okay, right? Got it? Now, what do you think? What should be the dimension? What should be the shortcut of length? Think about it. What should be the shortcut of length? Yes, very good. So it is always capital. So capital L, right? Capital L. Makes sense? Easy, right? Very good, Tejas. Now, what do you think about time? What is the unit of time? Everyone, think about it. What is the unit of time? Second. Very good. See, you guys are so smart. Second, right? Or SEC. And what should be the dimension? Think about it. What should the dimension? Yes, very good, Zillion, right? Capital T, very good, capital T. Okay, capital T. Very good, Varsha. Now, next is mass. So for mass, we know that the unit is kg, right? And dimension, I hope all of you are getting now. Dimension, yes, capital M, very good, capital M. What about electric current? So electric current, the unit is something called ampere. Ampere, A-M-P-R-E. Okay. And guys, I'll just tell you in upfront, my handwriting is horrible. Okay. So please let me know if you don't get anything, right? And the dimension is I. It is called as I. Okay. Current dimension would be I. Now next is temperature. Now what is the unit of temperature? I hope all of you studied Kelvin. Very good. See how smart you guys. Very good, Rohan. Very good, Shafan. Kelvin, right? and the dimension is actually K. The dimension is, we will be using K. Sometimes we use T also, but K will be using. Okay, got it? Now, moles and luminous intensity we won't be studying for now, okay? But these are the fundamental quantities. So we'll be using these 5 fundamental quantities, okay? Now, then your next question should be, what about the other physical quantities, right? What about force? What about light? What about energy? What about work and all those things, right? Now, they are called as, now, can you tell me what they can be called as? Right? Since they're derived from those, they're called as derived physical quantities. Derived physical quantities. Yes or no? Tell me, yes or no? Now let's start with a very basic one. Let's start with speed. Speed. How many of you know the formula of speed? This is general, Tejas. Okay, this is general, right? It's not in any chapter. Okay. Yes, very good. Distance by time. Very good, everyone. Distance by time. Now, if I tell you what is the unit of this speed unit, so you can just do, right? Distance unit is very good, meter. Very good, Rohan. See, you guys are so smart, right? And for time it is second. So it is meter per second, right? Meter per second or meter second power minus 1, right? Now, what do you think about dimension? Tell me, what about dimension? Think about it. Distance is which physical quantity? Distance is which physical quantity? Think about it. Length. Very good. So what is the dimension of length? Capital L divided by. Now time. What is the dimension of time? Capital T. So can I say that the dimension of this is nothing but L t to the power minus 1, right? Because 1 by t is basically t to the power minus 1, right? So this is what? This is the dimension or short form of speed. See, either you use L by T, either you use L by T, or you use L into T to the power minus 1. Okay, you cannot use both simultaneously. Okay, Safan, got it? Now, are you getting what is unit and what is dimension? That is the first thing that you should know about any physical quantity. Okay, now, what about acceleration? Acceleration or right, acceleration. So we know that speed and velocity both will have same unit and same dimension. Yes or no? Speed and velocity will have same unit and same dimension, right? Because both distance and displacement will be length. Now acceleration is what? Tell me. Acceleration is velocity per unit time. Think about it. Velocity per unit time. Or for now you can just think about it as speed per unit time, right? If you don't know the difference between speed and velocity, so you can just write speed per unit time. Okay, now tell me, what should be the unit? Think about it. What is the unit of this physical quantity? What should be the unit? Tell me. Think about it, guys. What is the unit of speed, right? Or you can just see, you can just convert it into fundamental quantities. Speed can be written as this: distance. Think about it. Distance per unit time whole divided by time, right? Step by step. If you don't get it, just start with step by step. Now, can you see that it will be what? Distance divided by time into time, which is time square. Yes or no? Yes or no? Tell me. Think about it. Because time into time, this will go down, right? I hope all of you know This properties of fraction. Yes. Anyone have any issue in this? Tell me, anyone have any issue in this? No, right? Shivansh, Piyush, Varsha, Adarsh, Tejas, Ananya, Farhan, Zalin, everyone is getting. Madhusudan, are you getting? Nishika, Nikhila, clear, very good. Nishika, you're okay, you're getting, right? Sanketi, you're getting, yes or no? Nishika, Sanketi, having doubt? Okay, very good. Now think about it. What I asked, unit. What is the unit of distance? Tell me, what is the unit of distance? Meter, right? Unit of distance is meter. Very good. What is the unit of time? Second. But it is square, right? So it should be second square. See how you can find the unit of any physical quantity. You don't have to remember, right? If you know the formula, you can find it. So it is what? Meter per second square. Yes or no? Tell me. Or you can just write it as like this. Meter second to the power minus 2. Anyone have any issues? Tell me. Anyone have any issues? Because usually what we do, usually we study the physical quantity, then we remember the unit, right? We have to remember the unit. But do you really think that you have to remember the units, or you can just derive it? Tell me. You can derive any unit, right? Yes. Okay. What about dimension? Tell me. What about dimension? What will be the dimension of this physical quantity? Again, distance it is L, divided by time it is capital T whole square. So it is what? L t to the power minus 2. Yes or no? Tell me, yes or no? Now, try to do this. I hope all of you studied about this physical quantity called as force. Yes. What is the formula of force? Anyone? Do anyone know what is the formula of force? Formula of force is something like this. I'll tell you, mass into acceleration. Okay, right? This is the formula of force. Don't worry, we will study everything in detail, right? I'll make sure that you all like physics. Okay, now, can you find the unit as well as dimension of this? Tell me, can you find the unit and dimension? Unit and dimension of this physical quantity of force. Think about it. Take your time and try to solve it, okay? Take your time. See, Newton is, again, Newton is the short form of the units, right? When you talk about Newton, right? Okay, this is the short form. No, Tejas, I'll talk about the basic unit. Yes, Rohan, very good, right? Very good, Rohan. Correct. In terms of fundamental quantity. Yes, Samarth, very good, correct. Samarth and Rohan gave the correct answer. No, Shivansh, right? Just think about this process and try to find it now. Think about the process, right? Mass, what is the unit of mass? Tell me, what is the unit of mass? Kg. And what is the unit of acceleration? We just found the unit of acceleration, which is meter per second square. Meter per second square. Think about it. Yes or no? Right? Yes or no? Yes, Rohan. Very good. So this is the unit, kg meter per second square. Now, since it is big unit, it looks like big unit, right? Then we gave it a shortcut, right? We gave it a shortcut name, right? Or short name, which is your Newton, on the name of famous scientist Sir Isaac Newton, right? Got it? But the actual unit is kg meter per second square. Got it? Now, what about dimension? Tell me, what about dimension? Right? Think about it. Yes, very good. Now, dimension of mass is capital M. Very good, Varsha. Very good. Right? Very good. And dimension of acceleration we already calculated, which is L t to the power minus 2. Don't you think that it is easy now? So this is the dimension, right? Okay. Yes, mlt to the power minus 2. Very good. So anyone have any issue in understanding what is unit and what is dimension? If you know the basic formula, can you find the unit and dimension of any physical quantity? Right? Okay, very good. Now let's come to our chapter, which is light. Okay, now when we talk about this chapter, light, what is the first question which our mind? Okay, the first question, these are the concepts that we'll be covering, right? The first question should be, how do we see objects, right? What is light basically? How do we see objects? Okay, second is how reflection occurs. What are the law of reflection, right? And then about plane mirror, I hope everyone have this plane mirror in your home, right? And then how image is formed by a plane mirror. Okay, got it? Now, the first question that I want to ask is, what is light? Tell me. Think about it. What is light? Can you touch light? Think about it. Can you touch light? Yes, very good, Rohan. Yes, Shafan. So can I say that light is a object? Can I say that light is an object? Yes or no? Very good, Samarth. So everyone, I hope all of you have watched the videos. Tell me, I hope all of you watched the videos. Yes or no? Right? They were interesting videos. How many of you enjoyed that? Very good. Right? Others enjoyed that. Okay? Very good. So, as most of you say, right? Light is a form of energy. I can say this, light is a form of energy. Okay? In short, I can say that it is a form of energy. It is a form of energy. Right? Which makes us, right, to see object, right? Which enables us to see anything, right? Got it? Easy? Okay. Now this is the definition according to our syllabus. Now when you talk about a more higher level definition, right? So it is basically, I'll explain what is the meaning of those terms, right? But first you just know that this is the definition. It is an electromagnetic wave. Electromagnetic wave. Okay, got it? Tell me. Right? It is also a basic kind of electromagnetic wave, right? So we will study this definition in detail about this after completing of our syllabus, right? Got it? So I hope all of you understood what is light. Yes, very good, right? Okay. So next I can say that yes, so we will discuss that in properties. Okay, we'll discuss that in properties, right? Now, next question. What are the properties of light? Tell me, what are the properties of light? Think about it. Before starting the reflection, we should know now what are the properties of light? Okay. Okay, so Shafan is saying it makes us see anything? Okay, yes. So I'll just note it down. It makes anything visible. Anything visible, right? Okay. Second, yes, it travels in straight line. It travels in straight line, right? Anything else? One more. Some of you are saying yes. Okay. It, so that those are not properties, Shifan, right? So the properties, it is made up of small packets of energy, small packets, or just packets of energy, just packets of energy, right? Not small, just packets of energy of energy called as photons, called as photons, right? Got it? Tell me. Okay. It, next. Okay, so most are saying it travels at very high speed, at very high speed. Okay, yes, very good, right? Very good. Okay, now light, again, light, when you talk about light or energy, okay, right, it have many different spectrums, right? So okay, I'll just write down. The best is white light. White light has, or white light has 7 different colors, or is made up of 7 different colors. 7 different colors, right? Okay. Now again, when you talk about, yes, which is Vibgyor, very good. Okay, we'll discuss this in detail when you talk about rainbow and dispersion and prism. Okay, now next topic that we will see, right? These are the properties. Next is something called reflection, right? Okay, reflection. Now, the next question is, how can we see an object? Think about it. How can we see any object? How can we see any object? Tell me. Tell me, everyone. Okay, just answer this, right? Just think about this. Suppose we have to see any object. If we have to see any object, then light should be, right? Light should be, okay. Yes, yes, with the help of light. So my question is what? Light should be on the object that we are seeing or on us. For example, suppose we have, this is a person and he wants to see this object, and this is a light source, right? This is a bulb, right? Suppose this is a bulb. Okay, right? Now light should be, okay, light should be on this surface, on this object, or light should be here. Light should fall here, or light should fall here on his eyes. Tell me. Yes, very good, right? Because, yes, light should fall on object. Very good. Now, if light is falling on an object, how can we see it? Think about it. How can we see it? Think about it. After falling on this object, right? this light should come to our eyes. Yes or no? Right? It should come to our eyes. Got it? Right? Now this process, it should have a process, right? This process is called as reflection. Okay, right? This process is called as reflection. Okay, got it? Got it, everyone? Wait, everyone, something happened. Okay. Okay, so I can say that we can see any object by the help of a process called as reflection. Yes, right? So the answer is reflection. And what is reflection? Tell me, what is reflection? If I have to define reflection, what can we say about reflection? Tell me. It is, tell me, bouncing back, right? Or change in direction of light when it falls on, when it falls on any object. Yes or no? Tell me, yes or no? Okay. Now, we already know that light travels in a straight line. Yes or no? Think about it. Yes or no? Now, think about this case. Suppose you are sitting in your room, right? Suppose you're sitting in your room. Okay. Suppose you are sitting in your room. We have a window like this. Okay. And you're sitting in your room. And we have sun over here. Right? Now, can you see that the sun rays, if they are coming in a straight line, right? There's roof. Okay. So it is preventing the sunlight to come inside your room. Yes or no? Tell me. Yes or no? Right? Still, you can see the objects inside your room without turning on the tube light or bulb. So how is it possible, right? If the light travels in a straight line, it should not reach to your home, right? Okay, but still you are getting the light. How this is possible? Think about it. Okay, try to close your window. Then don't you think that it will it be dark? Will it be completely dark? Yes, right? No, it won't be completely dark. Now you can still see the object. There'll be less light, but you can still see something object, right? Okay. Now, why? Because when you talk about reflection, okay, there are two type of reflections, right? Let's see. Okay, when you talk about reflection, there are two type of reflection. Okay, first is called as regular reflection, right? And second is called as irregular or diffuse reflection, or diffused reflection. Got it? Tell me, got it? Okay, think about it. What's the meaning of regular reflection? Think about it. What is the meaning of regular reflection? Suppose I'm having a plane surface, right? A smooth surface. Okay, this is a smooth surface, and light is falling on the smooth surface. Okay, right? And this is your straight line. Just suppose this is a straight line. So I can say that I can say that if light is falling on the surface, it is going back. Okay, it is going back like this, right? Okay, yes. So it is regular. Suppose this is angle some theta, the angle is theta, this is also angle theta. Okay, got it? So, yes. So if light is falling on a smooth surface, this is a smooth surface. Okay, right? It follows a specific path, right? It follows a specific path. That kind of reflection is called as regular reflection, right? Okay, but when you talk about surface, suppose this irregular surface, right? Irregular surface. Now think about it. When ray fall like this, right? It might go like this, it might go like this. Okay, it might go like this. Yes or no? Tell me. Think about it. Because the surface is not smooth. Surface is not smooth. So it can get reflected back in any direction. Okay, in random direction. Yes, got it? So these are called as irregular or diffuse reflection. Yes, very good. Now, we know that when you talk about irregular deflection, now this will again bounce back with any other object, for example, walls. Now, can I say that when you talk about sunlight, okay, we see sunlight in our home because of, tell me, because of, got it? Yes or no? Yes or no? Right? So I can say that even though we don't get the direct sunlight, right? We don't get the direct sunlight. That's true. We don't get the direct sunlight, but because of diffused light, we can see the object in our home, right? We can read the newspaper, we can do whatever what we want, right? So most of things that we can see, it is because of diffused light. Yes or no? Tell me, yes or no? Okay, very good. So I hope all of you understood what is your regular reflection and diffused reflection. Okay, now the next is, so we will be studying about regular reflection only. Okay, we'll be talking about regular reflection. Regular reflection. Okay, now when we talk about light, we already studied that we will have a smooth surface. So this is a smooth surface. Suppose this is a smooth surface. Okay, right? Wait, my line. Just try to draw once more. Okay, so this is a smooth surface. Okay, so this is the plane, right, at which a line will fall, sorry, a light ray will fall. Okay, now any line which is perpendicular to the surface, any line which is perpendicular to the surface, suppose this is a line which is perpendicular to the surface. Okay, okay, right, this line is called as normal. It is called as normal. Normal. Perpendicular means 90 degree. Yes, 90 degree. Okay, now let's talk about line. So when we talk about light, right, we will have a light which will fall on this surface at this point. Suppose it is falling on this point. Okay, got it? Now this light ray is falling on this surface. Yes or no? Tell me. It is falling on the surface at this point. So this is called as incident ray. Incident ray. Got it? Tell me, right? Any issues? Yes, very good. Incident ray. Now, obviously, if this ray is falling on the surface at this point, it should also go back, right? It will be reflected. Yes or no? It will be reflected like this. And this line is called as reflected ray. Very good. Right? This is called as reflected ray. Okay, very good. Now, so we have studied three parameters: incident ray, normal, reflected ray. Now this angle, what is this angle? Tell me. This angle is the angle between normal and incident ray. Okay, so let us say it as angle I, angle I. So angle I is called as incident angle. Yes, very good. Or angle of incidence, right? Or angle of incidence. Got it? And this is angle R. This is angle R. Very good. Very good, Shafan. So this is your angle of reflection. Apurva, my voice should not break. Guys, my voice is breaking. Tell me, is my voice breaking? No? Apurva, it might be your internet issues. Okay, right? Okay, now let's observe something. Let's observe something. Can I say that, okay, if I'm talking about this, can I say that this incident ray, normal, and reflected ray are meeting at the same point? Tell me, yes or no? Yes or no? Think about it. Yes? So I can say that they all are in same plane. Yes or no? Right? They all are in same plane. So let's see the observation. Right? Observation. So the first observation is, right? Incident ray, reflected ray, and normal lie in same plane. Lie in same plane. Got it? Yes or no? Yes, very good, Shafan. Okay, very good, Tejas. Second observation, right, which is basically the law of reflection, is this angle I is equal to this angle R, right? Or I can say that the angle of incidence is equal to angle of reflection, of reflection. Got it? Tell me, got it? Yes or no? Anyone have any issues? So these two are called as law of reflection, right? They're called as law of reflection, right? Now, same thing that we have to study in class 10th also, same thing we have to study in class 12th also, right? Same concept. Okay. Okay. Now, where we can see this reflection, tell me. Yes, that's why I told you to watch those videos. It's very easy to understand after watching the videos, right? Because you can visualize, right? Okay. Now, where we can see this reflection, tell me. What you used to see yourself? Tell me, guys, what do you see, right? Water, okay, and mirror, right? Mirror, basically. Yes or no? Mirrors. Very good. So I can say that, right? The object or this device or the equipment that we use, right, to see anything, right? To see us or see anything is your mirror. Okay, so let's talk about mirrors. Okay, now tell me, what are the types of mirror? Tell me, what are the types of mirror? Yes, so we have two type of mirrors. First is plain mirror, and second is called as spherical mirrors. spherical mirrors. And spherical mirror are of two types, concave and convex. Concave and convex. Okay, got it? Yes, very good. Got it? So plane mirror, then spherical mirror, which is like sphere. I hope all of you know what is sphere. Okay, it is like three-dimensional circle. Okay, like your ball, football, anything. It is your sphere, right? Now let's talk about plane mirror. Let's talk about plane mirror because it's easy. Plane mirror is easiest. Okay, now suppose I'm having a mirror over here, right? I'll just draw a diagram, right? Think about it because we'll talk about some more parameters. Wait, what happened? Okay, suppose we have this as mirror. Okay, this is your silver side because we know that mirror one side is silver, yes or no? Otherwise it will just be a glass, right everyone? Right? Okay, now there are some parameters that we have to know before studying this reflection. First is, suppose this is your object, right? Suppose we have this. Okay, this is called as object, right? Suppose this is your object, yes or no? Tell me. And this is the line, right, that we are trying to observe. Wait, I'll just make it bigger. Just make it bigger. This is your object. Now, tell me, what are the parameters that is associated? This point, right, is your reference point. Suppose this point is a reference point. Yes or no? Tell me, yes or no? And this is your object. This is called your object. This is your object. Right? So what is this distance called as? Tell me, what is this distance called as? Tell me, anyone. What can be this distance called as? Tell me, guys. Can I say that this is nothing but object distance? Object distance? Yes or no? Yes or no? The distance between the mirror and the object is called as object distance. Okay? Right? Got it? And it is usually represented by u. It is usually represented by u. Okay, object distance is represented by u. Right? Okay, Nishka, very good. And what is this height? Tell me, what is this height? Think about it. What can be called as this height? This height. Can I say that this height is nothing but object height? Object height. Okay, very good, everyone. Now tell me when you talk about mirror, right? Which side your image will form? This side or this side? Tell me, this side or this side? Object will form this side, side one or side two? Side one or side two? See, when you see your reflection in the mirror, it is inside the mirror, na? Right? Tell me, it is inside the mirror, yes or no? Right? It seems like there's someone who is behind the mirror, right? Got it? So the object will always form inside the mirror. Yes or no? Tell me, right? The object will always form inside the mirror in case of plane mirror. In case of plane mirror. Okay? So this is your image. This is your image. This is your image. Okay. Now, when you talk about Very big plane mirror. What is this distance called? Tell me, what is this distance called? Think about it. This distance is called as image distance. Image distance. And it is written by V. And this is your image height. Okay. Anyone have any issue in this? So I'll just write it as HI. HI, image height. I, like I will be in subscript. Got it? Tell me, got it? Okay. Now, what can we say about plane mirror? Can we say that in plane mirror, right, this object distance and image distance should be same? Tell me, can I say that in plane mirror, the object distance and image distance should be same? Yes, if it is very big mirror, I'm considering that this is a very big mirror. Okay, right? So this is one thing that we know, right? In plane mirror, you should write like this: in plane mirror, in plane mirror. This is only true for plane mirror. Okay, plane mirror. Image distance is equal to object distance. Okay, got it? Anyone have any issues? Tell me, anyone have any issues? Think about it, guys. No? Very good. Okay, so I hope all of you understood what is reflection, right? What is the various parameters, which is incident ray, reflected ray, what is law of reflection? Yes or no? Okay, very good. Right? Now, yes. So let's play one Kahoot. Okay, let's play one Kahoot. Ready, everyone?
Yes, sir, ready.
Okay, very good. Right? This is the Kahoot based on what we have studied. Okay, I won't be speaking while the Kahoot. Okay, so you just have to play the Kahoot. I hope all of you know how to play the Kahoot. Yes or no? Tell me.
Yes, sir.
Sir, we know.
Very good, very good. So the pin code is 3670755. 3670755. Join everyone, please join. Join soon. Okay, Nishika. So it is concave. Very good, right? Next. We will study about all these, right, in detail, but this is based on your observation. Yes, we use convex. Very good. Only Sanketi and Rajat gave the correct answer. 40 degree is the surface of mirror. Okay. Tell me, 40 degree is the surface of a mirror. What is the angle of incidence? 40 degrees making with the surface of the mirror. Think about it. What is the angle of incidence? Nishka, think once again. See, this angle is given as 40, right? This is 40 degree. So angle of incidence will be this, nah? Think about it. It will be this. Yes or no? Because this is the surface of mirror, right? This is normal. And we know that angle of incidence is between normal and ray of incident ray, right? So this is 50 only. 50 degree. Got it? Everyone got this? Got your mistake? Okay. Okay, very good. Next. Sanketi at the top. Very good. Last question. We just studied this. We just studied this. Everyone should give the correct answer. Everyone should give correct answer. Yes. Same plane, na? Same plane, right? We just studied this. If you remember, right? We just wrote it also here. The incident ray, reflected ray, and normal lie in the same plane. Yes or no? Okay. Got it? Right? Let's see the podium, everyone. Varsha, third. Very good, Varsha. Second, Piyush. Very good, Piyush. Who is first? Sanketi? Yes, Sanketi is first. Very good, Sanketi. Shafan and Adarsh are runners up. Very good, everyone. Okay. Very good, everyone. So thank you, everyone. Thank you for today's class, right? We'll solve more problems and we'll study this chapter, okay, in detail. Now, after this chapter, we will continue natural resources, okay? Okay, bye, everyone. Thank you, everyone. Bye, everyone.